Hello, ladies and gentlemen, and welcome back to our new episode of Biomedical Season 2. So today, not only is he the Associate Dean of Research and External Engagement at IMU, he has 18 years of experience in teaching and research, working in all USM, UITM, Chinese Academy of Sciences in China, UCSI, and now in IMU. I introduce to you Prof. Ho Boon Ping. Welcome, Prof. Ho.
Thank you very much. Thank you.
Okay, so without further ado, let's dive into our conversation. So, Prof. Ho, could you tell us a little bit on how has the general population's perception on applied genetics changed over the time?
Well, that's a very tough question anyway. The knowledge and the knowledge and the understanding about genetics in the general populations has actually advanced quite tremendously over the last maybe 10 to 20 years actually. When the first draft of the human genome sequencing was out, that's where the technology of the genomics has advanced in a lightning space actually, lightning pace. The lot of understandings, a lot of knowledge actually gained out of the human genome sequence, and then our understanding of diseases are also advanced. And then when the knowledge has already been applied to the clinical and bedside, has already been quite common nowadays. Take it for example, breast cancer treatment is very well received by general populations, and we are seeing a lot more other types of cancers, for example, treatments that uses genetic information to customize the therapeutics for the patient. So yes, it's actually getting a lot more well accepted by general populations, I would say, in certain manner.
So with movies such as Rampage, Jurassic Park, Jurassic World, where genetic engineering is being applied, how would you say that has changed the perception of students in studying genetics?
Well, Jurassic Park is history. I would say it's history because I remember when I watched Jurassic Park, I was in Form 3, or maybe younger than that, I'm not sure. So it is actually a very classic story about how DNA are being sequenced. At the time, it was really fairly an imagination actually. No scientific proof that can actually be done, but apparently it can be done. So that Dolly the ship is actually a big example. So yes, and that sort of information now has already been translated to a textbook in the undergraduate students. So you are being taught on how genetics, how DNA is being actually being used, being acquired in a lot of technologies. But as time advances, the understanding of the classical genetics among the undergraduate students are getting lesser. So you will see that before long, genetics alone is actually a subject in undergraduate universities, but now it has already been integrated to various types of the subject instead of a standalone subject. So in that case, some basics and fundamentals has already been covered. So that basics actually sort of lost. So people would tend to have less interest into that because you don't understand the basic, you don't understand the foundation. So it's actually a little bit difficult to move into the advanced types of genetics. But again, back to the story of Jurassic Park, actually gives that imagination actually gives scientists a hope to advance, and therefore we see now a lot of clonings been happening, and a lot of the advancement of the technology is actually happening. So it's always a pros and cons when we talk about this topic. And to students, I should ask you as a student, how do you think about genetics? Anyway? But to me, I think students are a lot more interested in nowadays on the applications of genetics in the very first question is how we make use of genetics in the general populations, and I think that would actually stays closer to your life as a student or when you graduate.
Alright, so Prof, let's dive into the fascinating world of the population genetics. So to start, can you give us a casual rundown about what is population genetics and how it sets itself apart from the other branches of genetics?
Well, genetics, population genetics, I used to call that as classical genetics. Why is it called classical genetics? Because it started off from the fathers of genetics, Mendel's. Gregor Mendel's actually started off, and we know that Mendel's ratio and whatnot. These are essentially the beginning of the population genetics. Now, what we study essentially is the allele and genotype frequencies, the differences of these frequencies compared to one population to another, and make it a little bit more layman manner. Like, why do I look different from you? That is where the population genetics comes into. And if we were to expand from comparison between one individual to another, expand it to a population. Why do a Chinese population look different from, for example, Malay populations? Okay. And that is where the population genetics comes in. And when you expand further, then why do certain populations has got higher prevalence of certain disease and why not in the other population? And that is also a subset of the population genetics. I hope that answers that question.
So is it like the population genetics is like a wide-angle lens of genetic research?
It is actually, it is. Well, if you look at genetics, I always say genetics has got 3 different branches. Now, why genetics? Because the ultimate goal of genetics is to understand why do you look in such manner, or why do you get disease but not others. That is where genetics, in a very layman, is that genetic equals to phenotypes. That's where it's actually, otherwise your genetics is meaningless. So that is one thing. Now, so if you were to go into that, it actually gives us the 3 different layers of genetics. One is that you study animal model in a lab and trying to understand why it works. You strangle the neck of the mouse and then take the blood or whatever you name it. Study in experimental model. And then the other half of is actually to look into a general population, so comparing a group of disease population compared to another group of normal populations and see why are they different, phenotypically and genotypically. Then you actually find out where the correlations between the genetic variations compared to a disease. Now the third layer of it is actually a lot more fundamental, and we actually see that where do we come from? Homo sapiens, where do we come from? And from that evolutionary process that forms the modern human today, for example. I take it for example, sickle cell anemia is my classic examples to give to students. Why sickle cell anemia occurs? Because they are mutations to help the modern humans to get adapted against the severe malaria attack. And therefore, the mutation changes the shape of the red blood cells, which protects against the attack of the plasmodium. Because there's also this compensations of it, because you may get abnormal red blood cells, but you actually save yourself from against the attack of the plasmodium. So that is an evolutionary process where we study the link between genetics and also traits. So that's the 3 layers of the studies of the genetics I always like to look into. And then overall is that the second and third layer is always what we call as population genetics. So that is about it.
Okay, so that's really fascinating. So how does this broader perspective of the population genetics contribute to the biomedical science research, diagnostic, and also public health initiative in layman's terms?
Breast cancer, again, is a very typical example. Certain people will have, now breast cancer usually is divided into 3-4 categories actually. Certain breast cancer patient will carry some mutation. And if you're doing tests on that, for example, estrogen receptor mutation, So if you're being tested to carry that mutation, then the medical doctor will start looking at what type of medication that fits you best to treat you, or to, I wouldn't say to cure, but at least to control your cancer, your breast cancer. So maybe in that case, tamoxifen is perhaps the better suits of that patient. Or if at all you have an epidermal growth factor, herceptin, may be a better one. So that could be another example, or a typical example of how we can actually use genetics to know a drug response of breast cancer. But that is part of it. The more general one that is closer to us in the Southeast Asian population, again, is another example that I always like to use. That is, it's a disease called Stevens-Johnson syndrome. Yeah, that's when you actually are being prescribed certain drugs, and often these are very common drugs. If at all you are carrying a mutation, and in a genomic region called HLA-B, you will likely to have 200-fold higher risk of getting Stevens-Johnson syndrome, because the gene expression will start responding to the drug that you're being prescribed with, and that causes your whole body being inflamed. You suffer with inflammation, and the whole body gets burned. That is what we call as Stevens-Johnson syndrome. More interestingly is the populations, the individuals that known to have the Southeast Asian ancestry, you have 15% of us are actually carrying the mutation. So that you actually see how closely related the population genetics as compared to our daily life. So in FDA, in the States, FDA has already instructed, if at all the patients come to you and you are being prescribed with this long list of drugs, and you are ordered to run a genetic test before you can take up the drugs actually. So that is another example that is where population genetics can come into the picture.
That makes a lot of sense. So now, Prof, let's talk about the ethics sides of the thing. So what ethical considerations come into play when we are driving into population genetic studies, especially when it comes into like privacy concern and also the data protection?
You have mentioned almost all the ethical concerns already actually, so you know better than me. Anyway, perceptions about population genetics is always a fear to most of our public populations here. Not only us in Malaysia, even to certain populations in the States, so minorities of the populations, because they do still have their own beliefs of where do they come from. Genetic and DNA sequence alone, I would say it's a very powerful tool that can even tells you the ancestry, your history, where do you come from. So people are feared about my own identity, my own secrets are being revealed, because they will say that if at all the genetic sequences are so powerful, what if I will reveal my secret to you and you can do anything on me? Partly it is true, but don't forget that we have 6 billion base pairs, who has such a free time to start looking at one base pair to another and trying to identify who you are. Yeah. So the privacy times there, I don't discount there is a privacy possibility of privacy leakage in that case, but at the same time, the chances of your identity being revealed, it's actually very, very low, because your DNA sequence is as if your fingerprint. You get your fingerprint in ID, right? If I touch my fingerprints on this table, I'm actually leaving my fingerprints here. So I'm revealing my ID here on the table. It's pretty much the same thing of your DNA sequence actually. So that is where it comes into when we talk about privacy. And to certain people are in a more even extreme manner and saying that I can create a bioweapon on it and kill the whole population's genocides. Possible, very possible. But that's where the ethics and regulations will come in. How can we regulate that part, actually? And at least at the moment, in Malaysia, or even in the States, this sort of making use of genetic information as a bioweapon has not happened even after 20, 30 years of the DNA sequence being reviewed, actually. actually. But nonetheless, there are always a backside of it, a drawback on it. There has been populations when they are being discriminated simply because of the abuse of the researchers in the genetic research genetic data that actually being used, where they are being claimed to have certain diseases, higher risk of getting certain diseases, and that causes the researchers are being sued in a law court, and they are ordered to pay a compensation of 700,000 USD. So there is when we talk about ethics, especially in genetic studies about ethics, it's always about how do we trust each other's. The general population trusts us as a scientist, and therefore I can share you my information. And scientists trust our populations, and scientists would not hesitate of sharing any of the genetic research that we are actually working on with that. So how do we create a trust between humans? That's where the ethics, the principles of ethics actually comes in. There's no right or wrong in ethics, especially in genetics. So that is where it comes into. But I don't discount that there is always the mad scientist trying to make use of genetics information and claim it to be something else. Yeah. I like to general populations again. Some people who do not know about the fundamentals of genetics. When we talk about ethics, a lot of interesting stories to talk about. Politicians like to make use of genetics and trying to claim on their own personal agenda. And myself actually experienced that many years ago, when a politician is trying to claim on a certain ethnicities that would have most ancient genes in the world, and therefore they are at higher rank as compared to the rest. And that sort of a claim simply derived from the genetic research that I actually did, which I never claimed that. So that is a real bad experience for me. And we had to stand up and make a disclaimer, make a rebuttal to that claim against the politicians. So general populations like you and not me, but you and the rest of behind the camera, understanding of what the principles of genetics is actually very important. Otherwise, ethics will definitely be abused, not only by scientists, but even by the general populations.
So going back on what you mentioned just now, you said how genetics can actually tell us where we come from and our ancestry. That's actually very interesting. So I know you've studied a bit on the shared signatures between different Aboriginal communities to populations of ethnic diversity and migrational history of human in the past. So all this, do you think that one day genetic studies and research can pull it all back down to where humans originate from?
Well, it can actually. In fact, we have already been doing that. 2022 Nobel laureate for medicine and physiology is a geneticist, evolutionary geneticist, Svante Pääbo. When he won the Nobel Prize and now is being announced as a Nobel laureate, I was jumping up and down because that actually shows a recognition of a genetics, in fact, a fundamental genetics are being recognized. So he himself is an evolutionary geneticist who studied not only Homo sapiens but the other Homo species, ancient genomics. Because of the population genetics itself, we study a lot, and that link us back to the origins of Homo sapiens are apparently from Africa. And that's where we comes up with the out of Africa hypothesis. So yes, we actually know, and well, it is not proven, but majority of the evidence has shown us back where our origin is actually. We are all from Africa. And then why do we look different from Africa nowadays is because that when we move into different climates and environments, we started to adapt to that environment changes. For example, those who actually move from out out of Africa all the way up to the Europe zone, colder climates, when you are being exposed to less UV exposure, UV light. So your skin pigmentation will definitely get lighter, right? Over not one generation, but many generations. You start getting adapted. Yeah, these masali getting bigger because they are staying in the colder climates. They need more fats to protect themselves from heat, heat preservation. So these are all the reasons why we get so look different. So back to it, yes, we have already been studying that. In fact, we know how the branch of the, not to know, but we are hypothesizing where the branch of our Homo species actually comes into. Yeah, we are actually studying where the humans originated, modern humans originated.
So actually in science, we already know where we came from.
I wouldn't say we know, unless you get a time machine and go back to millions of years ago and see where the humans comes from. Nowadays, we can only say this is a hypothesis, and majority of the evidence, scientific evidence, are in supporting on this hypothesis. The scientific evidence not only based on genetics but also from the archaeological evidence. When you study carbon-13, and we actually backdating on these fossils that we actually dig out, and then we study back on the genetic information that we got here, the genetic mutation, and then match it back to the timing of the archaeological evidence, and therefore it shows that yes, it seems that we are derived from Africa.
So all this study on ancestry, how do you think population genetics and all this understanding on humans and our past, how will it impact and contribute to our ability as biomedical scientists to accurately diagnose and treat a disease?
Well, it actually goes on to two different things. One is that where do we come from? That's fundamentally questions. Otherwise, the Nobel laureate of physiology and medicine won't go to a geneticist who study ancient genomics, actually. The medical part is that it comes in the question of where did the disease come from? How does the disease evolve? Because the evolution of disease actually directly or indirectly will affect the physiological adaptations of the human body. And I take it that's one of the examples. And by studying the understanding, just like you are studying history, why do you study history? Because history tells a story, right? We learn from the previous history experience, and therefore we know how to tackle on future. So exactly the same principles. Why we study evolution? Why we study on the ancient genomics? Because by understanding from the previous experience on the evolution and physiology of the disease, we know in future how would be the trend looks like and how can we treat on the disease actually. So that is where the really fundamental and underlying rationale of we studying evolutionary genetics.
Okay, so let's touch on a topic that I think everyone has had an interest in, genetic engineering. So CRISPR-Cas9 and all of that. Let's touch on the ethical concerns of it. So we know designer babies and gene editing in embryos have sparked considerable debate. Can you explain what these practices involve and why do you think they cause so much controversial in the general population?
A sudden switch on the topic from population genetics to genetic engineering. That's interesting. Anyway, I like that topic. In fact, I've been following up the CRISPR-Cas9 gene editing babies for many years actually. You know the story was because that the baby, the scientists had, so to speak, convinced a few couples, pregnant couples, and therefore to undergo the experiments. And then the baby was being injected with, the baby was being edited and therefore delivered. And the scientists were so happy to announce to the world that he has created a gene editing baby, and immediately that created a big hoo-ha. So the story behind it was that scientist has never gone through a proper procedures of research and ethics approval. His research protocol has never been reviewed and known to be something that is not being approved, basically. He Jiankui is the scientist, and then immediately he was being imprisoned by the Chinese government for 3 years. I think he was released last year. Now, the ethics part of it is that, first, from the scientific base, CRISPR-Cas9 is a technology, a very powerful technology, but there is also a lot of risk behind it because you don't know what's the consequence of you having a human that is being edited. So that is where the consequence is. You want to edit and make him to be a Spider-Man, it turns out to be Incredible Hulk. And it can be very damaging. So why am I saying that? Because there is always a risk of being offshoot, what we call. We know this is where we want to target. CRISPR-Cas9 just works like your Word document. Whenever paragraph that you don't like it or has a wrong spelling, you just have to move the cursor there and just delete and remove it. Yeah, that is where the simplified versions of the CRISPR-Cas9, because you can see and you can move, but you can't see DNA. So there is always a risk of being offshoot. You want to target the gene A and suddenly target and change the gene B. So that is where the offshoots comes in with the risk of it. That's the reason why, even though it is very powerful, until now there has never been a success clinical applications. Yeah, there are several in clinical trial, but never been approved by FDA as a clinical applications yet. Still a long way to go. Now, the second thing is that couples were HIV carrier. So the mother was, so to speak, being convinced that the baby, if being gene edited, the baby will not carry HIV. But HIV are now being treatable at early stage. That's one thing. Second thing is that whether or not the baby will carry HIV is another story. Yeah, and third, obviously, offshoot the baby become another type of Homo sapiens. We don't know. So that's where the mother was being convinced, but they are not being convinced in a proper manner because the mother was lower educated. So that's where the ethics actually protocol comes in, and these are all not being properly conveyed to the participants, and they have not been going through a proper procedures. Because very simple, putting myself in a very rational, common sense manner, if I were to go through this protocol in the research and ethics approval, I will definitely not getting through because the protocol itself is not right. None of the case, there are several clinical trials now, but before that there was not many actually making use of CRISPR-Cas9 for disease because it was just way too risky. So that is where the ethical concerns actually comes in. From scientific perspective, that's where the immature technology are not being catered. Second thing is that ethics, you don't make use of human as your white mouse in the lab. At the moment, it's not to the stage yet. So there's a lot of regulations when you want to make use of human samples for clinical trial. You have not gone through that. Yeah, you have to have clinical trial 1, 2, 3 before you can actually be approved by the FDA. So that is a long process on it. So the third ethical concern is that it is not being properly explained to the couples. And the fifth one is that, is that the fifth one? The following one is that whether or not the disease is about life or death, or whether or not the disease is something that is a must to be treated as the CRISPR-Cas9 technology is also questionable. So these are all few ethical concerns that people has been questioning when the gene editing baby is out.
Right, so looking ahead, Prof, so how do you see the role of genetic engineering evolving in biomedical science over the few decades?
Is the era, genetics actually moved really, really fast over the last 3 decades. since the first announcement of the first draft of the human DNA sequence, actually moving very, very fast. So I can't really predict what's going to happen in the next 5 years on biomedical science, on genetics, actually, honestly. It's way too fast than I could imagine. But what I can actually foresee is that there's a lot of opportunities out there, and it will be getting a lot more common. As a matter of fact, you can see in Malaysia now, there's a lot of biotech company that offers genetic tests to the clients, and I didn't mention that, but the general population's acceptance on the genetic test is actually getting more common, a lot more common. The fact is, so the opportunities of biomedical sciences graduates, it's a lot, because the industry will just expand, it will not narrow down. So and I think for the post-genomic era, for the next 30 years, maybe, will still be growing very fast. Engineering, genetic engineering always comes along with the fundamentals of science and fundamentals of genetics. It all goes hand in hand, actually. So you don't have to worry that you don't get a job, honestly. And CRISPR will definitely be a topic, and I have a feeling that maybe 10 years down the road, that the first CRISPR bedside application will be available. Genetic test is already available. Cancer treatment will be a lot more common, and our human survival against the non-communicable diseases and also cancer will be a lot more better. So yes, you have a lot of opportunities, actually. You are in the era of post-genomics. So you will a lot of opportunities, and just have to keep it up.
All right. So with such as advancements, so come to the important ethical consideration. What do you think will be the key ethical dilemmas we will need to address in the future of the genetic engineering?
That is something not. It goes back to my role as a teacher to you all, actually. Ethics itself is actually not something that can be written down and therefore you just follow strictly, because again, I say ethics it's about moral. It's more than moral. It's about trust. It's about norm. It's about belief. Even about religion. That's all about ethics, actually. So there's a lot of things that to be considered when it comes into ethics. How do we respect people? How do we respect our volunteers who participate into subjects, into your studies? And how do we respect science? It's actually something that is to be inculcated to all of you. I take it for example, if you do not know what the meaning of the genetic test is, you just have to come out there and sit down there and just tell all your clients that come and do a genetic test for me, and then I'll give you all sorts of interesting interpretation which out of nowhere that you can't interpret at all. That is very dangerous. Yeah, as a matter of fact, I don't mean to reveal, it's actually not right to reveal, but I've seen a lot of cases, that the genetic test has already been interpreted wrongly, and that created chaos to the clients, a lot of chaos. Yeah, this real case happened in Malaysia. I've seen at least 3 cases. So these are all the things that you just have to be meaning, and then keep up with your credentials. Very important, because then you know what are the regulations and what are the norms and practice in Malaysia. Because what you practice in Malaysia and what you practice in Singapore may be different. So these are all the characteristics that you need to hold on very strongly whilst you are in undergraduate, trying to understand that, and then you move on upon your graduations, moving into industry. That's where your ethics will come in naturally.
So are there any specific challenges you anticipate as genetic engineering continue to progress?
Yes, there is actually. Research has always been a challenge. common perceptions among the populations needs to boost up better. Although has been a tremendous improvement compared to how long have I been in genetics? Let me think. 20 over years ago. Quarter decades, quarter centuries. That tells me how old I am. So I don't mind telling you, actually. I started studying my PhD in 2000. So you know how old I am. And that was a time when the first draft of human genetics was out. So challenge, compared to 20 over years ago, the perception about genetics is actually very poor. My mom used to ask me, why you want to study genetics? That sort of question. Now people are, every one of us walking on the street would definitely, genetics here and genetics there. And we tell people they study genetics, whoa, so great. Yeah. That sort of perceptions are actually changing. But I think still a lot more to be done. A lot more in the sense that not the perception, but the understanding of what the principles of genetics is actually very important. Not only in genetic engineering, but genetics as a whole. What can we make use, and what are the risks, and how can we overcome that? So these are all the educations, these are all the counseling that we need to inculcate to the younger generations like you all. Yeah. By the time when you graduate, I might have pension already. Retire, then it's about your world to carry on the legacy. Yeah, that's true. Anyway, I carry my legacy of my late supervisors. Yeah. So now I'm passing it back to you all, and you guys carry on. I don't know what's going to happen to me tomorrow.
Okay, but going back to what we previously spoke about on the evolution of genetics and how it's going to change in the future, are there any up-and-coming subfields within the field of genetics that you see are starting to gain attention?
Back to my pet research again. Okay, evolutionary genetics is still something very new, at least to Malaysia. At least to Malaysia, because the environment here, the overall environment in Malaysia, and more general in Southeast Asia, is still very much skewed towards application. That sort of research, that you can gain instant return of investment. Like, for example, how can I make use of current understanding of genetics to develop a drug, to develop a test that can help my population immediately. Not only that, but can gain a lot of profits. That sort of research actually comes in. When you study genetics evolution and tell people that how do people come in, at least our government would say that this is the purpose of studying this. So that would be the challenge, actually, a hindrance for us to actually move along. Without having research funding, you won't be able to move in. And that sort of perception needs to change. And people like us need to be a lot more persistent to go against the wave, to work on it. But we still believe there's actually a lot of potential and there's a lot of value. In fact, not a lot of value, is in value to actually study the evolutionary genetics, because from the evolutionary perspective, you understand what population is all about. And without knowing the population's genetic, the information of population genetics, you won't be able to develop a drug, or you won't be able to develop the test, or you won't be able to help our population. Yeah, these few examples I give you is a very classic one. Yeah. The frequencies, the risk of the HLA-B tip, for example. Education is very important. We need to educate people. Another field of interest would be the genetic counseling, where people are always being undermasked. And I think genetic counseling is also very important. You may just have to cut it off if it's too long, but I'd just like to share a story about Angelina Jolie. Everyone of us know about Angelina Jolie. Yeah? Her mother died of breast cancer. Her sister died of cervical cancer. Is it cervical? No, ovarian cancer, sorry. Ovarian cancer. Why? Because the whole family, including herself, carry a BRCA mutation. So the genetic counseling told her that you have 85% of risk getting a breast cancer, and another 50% of risk getting ovarian cancer. Because of the genetic counseling given, so she did a brave move that shook the world, that is undergo a mastectomy. Right? So that changes her life, because then her risk of getting breast cancer dropped from 85 to 5%, or less than 5 actually. Then subsequently she removed her ovarian. So she has no risk of getting cancer anymore. So that genetic counseling is also something very important, and we don't have a genetic counseling. So, but we have a lot of genetic counseling, but it's actually not in the hierarchies of being recognition at the moment, unfortunately. But these are where the policymakers should come in and start considering how important is all these things are related. Why am I talking about this one? Because genetic counseling, again, you need to understand what the basic and classical genetics is all about before you can counsel your clients. And to understand population genetics, obviously, Mendel's, it's all about evolution. So it's all in one line at the end of the day. So that is where the few perspective and these few challenges that we need to take into consideration for the next several years, hopefully.
So as we wrap our discussion, Prof, what key message you hope our listeners have gained from today's conversation?
Pass your exam. Well, I think to first is understanding the basic principles. A lot of students here always feel boring of why lecturers are giving us all these basics, and at the end of the day, we don't make use of it. But no, basics is very important. Yeah, principles are also very important, and I appreciate what the basics are all about. Second thing, it's there's a lot of opportunities out there. You just have to make use of your knowledge, and then you can be there. And not only you are in the industry, but hopefully you can lead the industry. I think that is also something that I'd like to emphasize a lot to the younger generations over here. Don't let the industry lead you. You lead the industry. Yeah. So that's where the leadership comes in. Yeah. Steve Jobs changed our world. Yeah. Why? Because he leads the industry. So you lead the industry. So I think in life science, there's a lot of opportunities for you to lead the industry. So something to think about that. You just have to be a little bit more innovative and a little bit more creative, and more importantly, more hardworking. So that's something. Third thing is moral and ethics. It applies not only in science, not only in genetics, but in any day, any moment of your life. Ethics and moral is very important, and put yourself in the highest position of the ethics. And that is the three messages I'd like to share with all of you. Not solely about genetics, but more about how you make use, the underlying meaning behind the genetics is the three most important things.
So I guess it's the end of the day. So a really, really huge thank you to our guest, Prof. Hall, for sharing your expertise and also your insights with us today. And thank you to our listeners for tuning in. So if you found out that today's episode is informative and fun, don't forget to subscribe to our podcast and leave us a review. And if you have any questions, comments, or suggestions in a future episode, we would love to hear from you. You can reach out to our official Instagram page, @ISBA_IMU. So until then, stay curious and stay informed. See you next time. Bye bye.
Thank you. Bye bye.